The calendar year 2023 broke records, becoming the hottest globally, reaching approximately 1.5 degrees Celsius above pre-industrial levels. This kind of data often drives calls for action and ambitious decarbonization goals, but what does that record-breaking heat really tell us about our future, even with those ambitious plans?
That's a crucial question. Many nations and non-state actors have indeed set significant decarbonization goals to stabilize global temperatures. Yet, as we see years like 2023 push closer to that 1.5-degree threshold, it highlights a pressing need. We can't just predict the average warming. We also need to understand and predict the hottest years that might occur, even if we rapidly decarbonize.
So we're not just looking for the trend line, but the peaks within that trend. How do researchers go about making those more specific predictions, especially given the complexities of climate models? I know the source text mentions they trained neural networks on an ensemble of global climate models.
That's where the new approach comes in. Researchers trained neural networks on an ensemble of global climate models. The innovation is that they then used historical observations as input to these trained networks. This process effectively constrains the inherent uncertainty in climate model projections by grounding the predictions in the actual current state of the climate system. It creates what they call a truly out-of-sample prediction.
A truly out-of-sample prediction. That sounds significant. Does it mean they're testing the models on data the models haven't seen before, making the predictions more robust?
Precisely. It means the models aren't just recapitulating what they've already learned from the same data they were trained on. The study showed that for the historical period, these neural networks made highly accurate predictions of the hottest historical years. This was true even though the underlying global climate models themselves had a wide range of climate sensitivities. This suggests the method is quite robust.
That's reassuring for the model's accuracy, but what do these constrained and refined predictions tell us about the future, particularly concerning that 1.5-degree target we just spoke about?
The findings are quite stark. Even if the most ambitious scenario plays out, net zero emissions are achieved by mid-century, mean warming is virtually certain to exceed 1.5 degrees Celsius. The research also shows there's an even chance of warming reaching 2 degrees Celsius.
So even with aggressive action, exceeding 1.5 degrees seems almost unavoidable, and 2 degrees is a real possibility. What about those individual hot years you mentioned earlier? How much hotter could they get compared to 2023?
That's another critical point the study addresses. They found a high likelihood of individual years being at least 0.5 degrees Celsius hotter than 2023. This is projected to occur even in the most ambitious decarbonization scenario.
A full half-degree hotter than an already record-breaking year like 2023. That has profound implications for extreme weather events, public health, and infrastructure resilience. It seems these predictions from a paper describing a new model really underscore the urgency and the potential severity of our climate future even under optimistic scenarios.
They certainly do. The key takeaways from this research are that we need to prepare for exceeding 1.5 degrees of mean warming, and we should anticipate individual years that are significantly hotter than anything we have experienced so far, even if global emissions are drastically reduced.